Nesting, iteration, and selection. Sometimes there may be a need for two conditions to be met one after the other. For example, write a segment of code that outputs parking lot access to high school senior drivers who have parking passes. All students who are not seniors will be denied access, and all seniors who don't have a parking pass will also be denied access. In this scenario, let's first ask the question, is the driver a senior? If the answer to that question is no, then access is denied. If the answer is yes, then we have a second question to ask. Does this senior have a parking pass? If the answer is no, then access is denied. If the answer to the second question is also yes, they are allowed into the parking lot. Let's turn these ideas into code. Here is a sample solution. We have two variables, senior and pass. This one holds a y if they are a senior, and we'll say an n if they are not a senior. Also, they have a parking pass variable. So if they have a parking pass, it's a y. If they do not have a parking pass, it is set to n. So we have if senior is equal to n, then access denied. Else, and then here, we have some more nested statements. So inside of this else statement, we have indented, and we have another if-else statement. So if they pass the first if statement and they get into this else, then we have if pass equals y, print access granted, else print access denied. So in this case, where they are a senior and they do have a pass, it will output access granted. Here is the same solution written in AP pseudocode. The nested if-else statement highlighted in red on the previous slide works to produce the desired output, but there's a better way. Nested if-else statements are written with the else if next to each other, ELIF, as shown below. It is short for else if. So here we have if senior is equal to n, print access denied. Else if pass is equal to y, print access granted. Else if pass is not equal to y, print access denied, no pass. Let's walk through the code together. First, we see if senior is equal to n. If this is true, it prints access denied, not senior. And that's printed, and we are done. The computer will not even look at the else if statements here. However, if senior does not equal n, the computer will then consider the next option. If senior does not equal n, we're going to check to see if the next condition is true. Is the pass variable set to y? If it is, we will run the code highlighted in red here. In this example, pass is set to y. So the statement access granted will print to the screen, and the computer will not even look at the last else if. What if pass was not set to y? We are now going to check to see what happens if the pass variable is not set to y. So here we have set pass to n. That would make the last else if condition true, which will run the code highlighted in red. In this case, if we have reached this step, access denied, no pass will print to the screen, and the program is finished. You can use as many else if statements that you want, but it must first begin with an if statement. This code will cause a compiler error because it does not begin with if. You can see it starts with elif instead of an if statement. Without an if statement, errors will occur. However, you can use an else statement without the if after it. Here's an example. We want a program that will see if x equals 3, 6, or 9. So we have x equals 7. If x equals 3, print x equals 3, and so on for 6 and 9. Else, print x is not 3, 6, or 9. The output here will be x is not 3, 6, or 9.